Start this evening with a few words of thank you. I don't want to take very long because I don't want to hold you late again tonight. So just a few words of thanks. First to the elders for having this. I think this is an important series for lots of reasons, but especially for young people. And so I want to thank the young people who've been up here every night. You've been right here at the front and paying attention, best I can tell. And we appreciate that. And we're glad that you have as many young people in this church as you do to train and to teach about the wonderful God we serve. And to all those who've taken us out to eat and been so hospitable to us, and for the way you've received us here today and the rest of this week. It's been a blessing. And so I think I speak for Marilyn that we've just been so happy to get to be with you. And I want to say again to the elders, thank you for asking me to bring Marilyn too, because that really matters. And it's been a wonderful week in large measure because of that. And she's pretty tough. She's heard these lessons before, and she stays awake. That's pretty good. So thank you for being here again tonight. I have chosen to finish this series with this topic, fearfully and wonderfully made. I'm not going to turn to these passages, but you know Genesis 1:26 clearly describes that God made human beings as a distinct creation in His image. There is no way, folks, you can get evolutionary theory out of Genesis 1. You probably know there's a lot of people in the, quote, broad Christian world who try to make evolution and creation work together. But if you mean the general theory of evolution and the account of creation in Genesis 1, they cannot be harmonized. They're completely different approaches to how life arose. There is not evidence in the Bible that God chose to create us by the means of evolution over time. So tonight, I want to turn to the specific creation of mankind. I want to talk about us. I know you're probably interested in roaches. We are in Florida because they're all over the place. But I know you're mostly interested in us and where did we come from. So tonight, we're going to complete our lectures by turning to the topic that's mentioned in Psalm chapter 139. There's my thingy. And verse 13, for we are fearfully and wonderfully made, and that we know very well. So Psalm 139 describes. So I want to talk to you a little bit about how fearfully and wonderfully we are made. And I'll remind you again briefly of our theme passage, Romans 1:20, that by examining the things that are made, we can come to be convinced there is a master maker, a designer of all that we see. And so we're there again tonight. So I thought I'd start with our favorite author, Richard Dawkins. And I keep telling you, I refer to him a lot because he has been granted the privilege by Oxford University in England of speaking to the world about the scientific method and about science in general. So he's really looked upon as a leading light to tell us all about these things. And he is thoroughly evolutionary in his view. So I brought the book again tonight, The Blind Watchmaker, and you'll see several quotes before you from this book. And I think it's very interesting that of course the book is called Blind Watchmaker. But he starts the book on page 1 by saying biology is the study of complicated things that give the appearance of having been designed for a purpose. That's on page 1. So he knows, as well as we all do, everywhere you look, it sure looks like things were designed. So then he proceeds on page 3 to talk about airplanes and how they're constructed. And then he says, the process by which an airliner came into existence is not fundamentally mysterious to us. Humans built it. Would you say amen to that, class? That's not a hard question. And then he proceeds, but what about our own bodies? Each one of us is a machine, like an airliner, only much more complicated. Are we in agreement? Yes. Were we designed on a drawing board too, and were our parts assembled by a skilled engineer? The answer is no, says Mr. Dawkins. It is a surprising answer, and we have known and understood it only for a century or so. He credits Darwin with having discovered how you got here. But you weren't designed. Certainly not. Then he proceeds, a few pages later, to talk about it this way. We shall explain its coming into existence as a consequence of gradual, cumulative, step-by-step transformations from simpler things, from primordial objects sufficiently simple to have come into being by chance. You sitting here came about over a long time by small changes. The original things could have been happening just by chance. And so what we really have, folks, is a blind watchmaker, and it's called natural selection. I'm very thankful that there are a good number of other scientists living today that do not agree with Dr. Dawkins. And here's one of them, Dr. Michael Behe, in his book, Darwin's Black Box. He says, and he quotes Richard Dawkins too, Richard Dawkins can simplify to his heart's content, but because he wants to convince his readers that Darwinian evolution is a breeze. In order to understand the barriers to evolution, however, we have to bite the bullet of complexity. So I've had people tell me this week they don't understand a word I'm saying, but they are stupefied. And maybe that's a compliment, I don't know. I meant to be stupefied by the complexity of everything. They mean they didn't get anything I said, so it's okay, but you left here stupefied. Complexity, ladies and gentlemen, has become more obvious to us than it has ever been. And Behe is a master at explaining that. Biochemistry has demonstrated that any biological apparatus involving more than one cell, such as an organ or a tissue, is necessarily an intricate web of many different identifiable systems of horrendous complexity. Don't you love that? He's straightforward about that and very plain. And then here's a great book I'd recommend it to you as well by Jeffrey Simmons, called What Darwin Didn't Know. Jeffrey Simmons grew up in a family of atheists. He was not a believer at all. He became a believer after he became a medical doctor. And he wrote this book out of his own personal experiences. It's a book rich with many quotes about things, and he's really taking the human body and looking at every part of it and showing you why it had to be designed. So here's one of his quotes. Every aspect of the human physiology has multiple facets, steps, purposes, managers, feedback loops, anticipated outcomes, and double checks. Every function is too complex to have been formed by slow, accidental changes that luckily fit together. He became convinced that explanation Dawkins gave is just not possible. It's not possible. And I think you believe that too. But the evidence for that is stronger than it's ever been. So, that's my introduction tonight. And I'm going to turn our attention now to the fearfully and wonderfully made immune system which you and I have in our bodies that keep us alive. And I want to introduce you to a book that I have learned about just in this last year called Immune, A Journey into the Mysterious System That Keeps You Alive. It's written by Philip Detmer, who's the creator of the Kurzgesagt website. And his goal in life, Philip Detmer's not a scientist. His goal in life is to take very complex things and explain them in simplest as possible terms. And I can tell you, I have thoroughly enjoyed just reading this book. Today I got to spend a lot of time reading it again. And so I want to share with you a few things, and mostly built on how he does it, but being true to what we know about the immune system. And I want to have a little fun with you too while we're at it, because this guy's funny. He really is. And so we'll be sharing some things specifically from him. So let me get myself together here. Everybody should have gotten one of these, right? Did you? Does anybody not have one? Okay, I gave you a one-page summary sheet, and we're going to be referring to it in just a moment. Here's what Behe says about the immune system. Dr. Michael Behe. Diversity, recognition, destruction, and toleration, all of these and more interact with each other. Whichever way we turn, a gradualistic account of the immune system is blocked by multiple interwoven requirements. Your immune system, ladies and gentlemen, is one of the most complex things there is. And I hope to get that across to you. Everywhere you look, an evolutionary answer to this is blocked by the complexity of the way things really are. So, I'm going to start now with the opening paragraph in Mr. Detmer's book. And you'll see what I mean about this gentleman. This is page XI of the introduction. Imagine waking up tomorrow feeling a bit under the weather. An annoying pain in your throat and your nose is runny and you cough a bit. All in all, not bad enough to skip work. You think as you step into your shower pretty annoyed at how hard life is. While you are totally being a whiny little baby, your immune system is not complaining. It is busy keeping you alive so you can live to whine another day. And so while intruders roam your body, killing hundreds and thousands of your cells, your immune system is organizing complex defenses, communicating over vast distances, activating intricate defense networks, and dishing out swift death to millions, if not billions, of enemies. All while you're standing in the shower mightily annoyed. Which is a real shame because there are not many things that have such a crucial impact on the quality of your life as your immune system. It is all-embracing and all-encompassing, protecting you from the bothersome instances like common colds and scratches and cuts, to life-threatening stuff like cancer and pneumonia, to deadly infections like COVID-19. Your immune system is as indispensable as your heart and your lungs, and actually it's one of the largest and most widespread organ systems throughout your body, although we don't tend to think about it in these terms. Extremely complex. And we ought to think about it a little more than we do. So I want to tell you some things about the immune system. And I thought I ought to mention one other thing now. I'm going to go now to page 6. Your immune system is not a singular thing. It is a complex interconnection of hundreds of bases and recruitment centers all over your body. They are connected by a superhighway, a network of vessels, similarly vast and omnipresent as your cardiovascular system. Even more, there's a dedicated immune organ in your chest as big as a chicken wing that gets less efficient the older you get. And by the way, they say at 85 it's dead and gone and you can't even use it anymore. We'll get to that in a minute. On top of organs and infrastructures, dozens of billions of immune cells patrol either these superhighways or your bloodstream and are ready to engage your enemies when called. Billions more sit on guard in the tissue of your body that borders your outsides, waiting for invaders to cross. On top of these active defenses, you have other defense systems made up of quintillions of protein weapons. Remember that word? That can think of as self-assembling, free-floating landmines. Your immune system also has dedicated universities. Did you know this? Where cells are trained to fight and how. It possesses something like the largest biological library in the universe, able to identify and remember every possible invader that you will ever encounter in your entire life. That's an overview. So here we are, ladies and gentlemen. The human immune system in big picture. We're going to start out and describe the basic parts to you. And then we'll get down to some details as much as time allows. So your human immune system consists of three major parts. Let me blow this up a little bit. There are anatomical and physiological barriers. Your skin, ciliary clearance. There's lots of hairs in your body. They're extremely important. You know that, right? Tell me one place, class, where there's a whole lot of hairs that protect you. In your nose, but not as many there as lots of other places. Give me another big one. Say it again. Ears. Your ears. Yeah, there's hairs in your ears. But how about inside of you? There's lots of hairs in your lungs. Cilia. And they're extremely important. And we're not going to talk about those tonight, but just understand that's part of your protection system. And then there's a low pH in the stomach. It has an acidic pH that helps kill things. And there's lysosome in tears and salivas. When you start putting stuff in your body and in your eyes, there's things there to help you kill bad things. So, there's anatomical and physiological barriers. Let me spend just a little time with you on skin in just a minute. But then there's the innate immune system, and there's the adaptive immune system. The innate immune system has cellular and humoral parts to it. So does the adaptive. And these two work together like a hand in a glove, and you have to have them both to be able to defeat the enemies that are coming after you all the time. So, let me talk with you just a little bit about skin. Your skin is the largest organ you have. The total surface area is about 2 square yards, about half the size of a pool table of all of your skin. And you need to be on your knees tonight thanking God for your skin. It's your first biggest protection against enemies. Every second, you shed around 40,000 dead skin cells. Did you hear that? Every second, you shed about 40,000 dead skin cells. I told the kids last night that's why you need to bathe every day, partly. And an average square centimeter of skin is home to about 1 million bacteria. They're everywhere. Your skin also has built into it some things that protects you from certain kinds of enemies that it exudes that help chop up things. So your skin is critically important. I can't spend much time on skin, but I'm telling you, your skin is your first line of defense. It's critically important. There's much more that should be said about that. There's a whole chapter about that in this book. But let's talk about the innate immune system. What's special about it is that it's fast. It's your first response once enemies start getting inside your body. It is non-specific in the sense that it attacks anything that's considered other than yourself, which leads me to making this point about your immune system. One of the keys to your immune system is that if you let it go wild, it'll kill you. It's critically important that your immune system can distinguish between you and everything else. So is this thing we're looking at or examining other, or is it self? And it has to be able to tolerate self while it kills other. That's the way it has to work. And if it doesn't, you're in big trouble. Because the fact is, it's so powerful, it can kill you in minutes. Your own immune system can. So, this first innate system is non-specific. It goes after anything that's other and wants to eliminate it. It's fast response. It happens immediately and on into the first hours and days of your problem. But it doesn't present any memory. In other words, it doesn't leave anything left over after it's finished that helps your body remember, oh, I know that enemy. The adaptive system, on the other hand, is very specific. In fact, it's so specific that when I show you how that works, the T cells and the B cells in your body are specific to a specific enemy. And that's why it said a moment ago that you have the largest library in the universe stored in your immune system. Because your body has the capacity to produce some kind of a T or B cell for any enemy that you'll ever have, as we'll show you in a minute. So, it's specific, but it has to be primed, and it's therefore slower than the innate system, and it produces memory cells that stay with you, class. That's why older people than young children can resist disease better than the youngsters can, until that object here that we're going to talk about in a minute starts going away, and then older people fail as well. But the adaptive system is specific, primed, and thus slower, and produces memory cells. So now my job is to help you see how this works together, and we have a little video I want to show you and share with you. And by the way, I meant to mention to you that Mr. Detmer's book is thoroughly evolutionary. So while I recommend it to you for interesting and fun reading, I don't recommend it to you for how he explains how this got here. Because every other page is how, isn't it amazing what evolution did? Folks, when he describes the things and shows you how intricate and amazing and complex they are, and then he goes on to say, and isn't it interesting what evolution does? There's no explanation how evolution could do that. It's just stated as if we know this and we don't have a clue. So, if you're going to read this book, read it with discretion. And the video I'm about to show you was produced by his company. So, Mr. Cody, are you ready back there? Okay. By the way, may I say another word about the IT staff? Cody has spent a lot of extra hours on this, and he's practiced so he can help me and follow my instructions from the back. And if that doesn't work well, it messes me up. So I want to tell you how dependent I am on Cody. And then the rest of the team back there helps, and of course, they've all been wonderful. So please, again, you help me thank them, would you? All right, Cody, don't mess up now, because I've really set you up as a champion. Nope, not for this. All right, so here we go, class. This is an introduction now to some of the major parts of the immune system. You see, we have lots of pathogens. Those are enemies. And then here are some of the soldiers that help protect you and systems that help protect you. And we're going to go through this now, one piece at a time. So, Cody, let's go. First, you can see the interlocking here. All of them are interested in killing enemies. You see how all these lines here, and stop right there. Whoops, I missed it, Kobe. Back up just a little bit. There you go. Right there. That's good. What I want you to see here, class, is this over here is the innate system. And this is the adaptive system. But do you see how all of this is interwoven? There's connections everywhere. All of these things work together and they depend on one another. That's what I want you to see in this diagram. Your immune system is extremely complex and highly dependent on all the parts. It works together. And as Dr. Behe says, every time you try to explain that by evolution, you get blocked because you got to have this, and this all there. So how do you get it in little tiny steps over millions of years? You don't. It's not possible. Okay, proceed. So here we have a man. We're going to show you now. There's a lymph system besides. Stop right there. There's a lymph system in addition to all the normal systems you think about. I don't know how much you know about this, but your body has a system all through it that's called lymph. And there are two major organs, the thymus sitting right there. That's the little organ I was talking about. And the spleen sitting right here. That are the two major organs of the lymph system. Go ahead now. And then there are lymph vessels all over your body. That's like a superhighway. And stop right there. Now I want to introduce to you some of the soldiers in the army in your immune system. So let me tell you a few words about each of these soldiers. And I've written notes so I don't forget these guys. The first big ones here are called, I think I left one out here. These big ones are called macrophages. The macrophages are called, you know what macro means, everybody? What's macro? Big. And phage, anybody know? Eat. So these are big eaters. Macrophages. They live up to several months. They patrol and pick up garbage and dead cells all over your body all the time. Somebody asked last night about recycling and refuse. Folks, if you didn't have macrophages helping patrol your body all the time in massive numbers, you'd be a big glob of garbage. If they get annoyed, they're scary fighters. They're your first line of defense. They are called the local captain of the innate system. They tell others what to do. They help manage the system. And after the fighting is over, they help clean up the mess. The true battlefield is made into a friend construction zone, thanks to the macrophages. Lots of jobs that they do. May I welcome to you the macrophages. That's the first group. Cody? Next, stop. These little guys are called the dendritic cells. Aren't they ugly? This guy tries to make these soldiers into people. And that's the way he talks about them. So the dendritic cells, these little pink guys here with eyes, are your intelligence officers. They are careful, relaxed sentinel cells. They identify the kind of enemy that is infecting you. And they make the decision whether they're going to go about and activate the adaptive system, which hadn't started working yet. So they are a key connection between the innate and the adaptive system I told you about, the dendritic cells. All right, also coming in here, just go a little bit further, Cody. Right there. Good. These guys are called the T cells. And there's several different kinds of T cells. And may I introduce you to the T cells? They're the most important of the adaptive immune system. Without them, you're dead. And each individual T cell is born with one specific type of receptor. And it's able to recognize one specific enemy. Get that. This is the specific side of your immune system. So they are designed to take on a specific enemy, not just everybody. Macrophages, on the other hand, they'll attack anything that they think is other. Okay, go ahead now. Stop right there. May I introduce you next to the B cells? These are another part of the adaptive system. They are very large relative to the T cells. They originate in the bone marrow back here, as do the T cells. They are made in the millions and billions, each one specific for a specific enemy. So both the T cells and the B cells are specific. And the B cells produce antibodies, basically B cell receptors. And both of these types of cells have to go through training in order to be the proper kinds of fighters. And your body provides the training. All right, next. Stop right there. I like these the best. These are called neutrophils, and let me tell you what he says about them. They are crazy, suicidal Spartan warriors. They are like a chimp on coke with a bad temper and a machine gun. And their job in life is to kill stuff. And you set them loose, they kill stuff inordinately. And they have all kinds of ways to do it, which I'll describe a little bit more in the future. But neutrophils are your crazy bombers that'll kill anything. But they also are guided so they don't kill you. Except when it really gets tough at the beginning, they kill some of your cells because they just get after everything. So you have to control these guys. And built into your immune system are ways that T cells are controlled so they don't kill you. Sometimes that messes up and they do start killing you. I'm sorry to say. You've heard, haven't you, of autoimmune diseases where your own body is beginning to attack you? That's a terrible thing because it's not good to have those guys against you. So here are the major forces of your army, folks. These are the big dudes. And it's better than Star Wars, kids, I'm telling you. All right, so go ahead, Cody. What we're going to do now is we're going to talk about a way this thing starts working. And here you are, innocent little guy, surrounded by enemies. Everywhere you look, there are enemies. You are being attacked inside by cancer cells, outside by viruses, bacteria, all kinds of enemies. And so you cut your finger. Stop right there. You cut your finger. Folks, you just invaded the skin. Imagine a rusty nail has cut a hole in your finger. And he says, big deal. You put a Band-Aid on it and you go on. Folks, that is no big deal to what's down inside that finger. It's a huge deal. And the story we're going to talk about next is what happens next once you cut that finger and you open up the skin so that enemies can get inside and face your army. So here we go. So he says, big deal. It is a huge deal. Look at this hole. And here come the enemies piling in there and finding this wonderful, warm, hospitable place where they can have babies and spew out stuff. See this guy spewing out his stuff behind him? I mean, they're making a mess in there. And they're starting to make big troubles for you. And look at what starts happening. You see these these are damaged cells. They start screaming, come help me. And they send out cytokines. Stop right there just a second. Messages, chemical messages to activate people. You got to come help. We got a major surgery problem here. We got invaders everywhere. So cytokines are being sent out. And the first one to respond is the macrophage. Big guys. So go. Stop right there just a second. If you said a common cell in your body, average size cell, was compared to you, stick with me here, then a macrophage, go on just a little bit, Cody. A macrophage would be like a blue rhino compared to you. Stop right there a minute. So he's huge on a cellular level. And you don't want to mess with him, just like you didn't want to mess with the blue rhino. And if you get a blue rhino stirred up, you get out of his way. Same happens with a macrophage. You stir him up and he's big trouble like this. Go, Cody. Now watch the macrophage. You're going to watch how he works. You see, he can stretch out his little fingers there and suck them in. And once they get sucked in, they're in trouble because they can't escape. He wraps them up and he puts acid on them. He spews them up and spits them out. Stop just a minute, Cody. This guy takes those mean enemies. He sucks them in alive, puts acid all over them, chews them up, eats what he wants, and spits out the rest for other things to feed on. And by the way, did you note that I mentioned about them? They're going around your body patrolling and picking up garbage all the time. They pick up leftover stuff in your bodies like dead things and things that are just leftovers from other operations. And they eat them as much as they can and then spew out the rest for some other little thing to eat it. So it's perfect recycling. Macrophages are very important. So here he comes. He's been called to help in this very terrible battleground of enemies. So let's watch now, Cody. As the macrophages come on. Look, this one's getting full. So he says burp, and I'm full. Stop right there just a second. These guys can eat about 100 bacteria before they get full, but in short order. But they do get full, and they get tired. So here we are. So we call on other helpers, and here come the neutrophils. These are the chimps on coke with machine guns. And they come filing in out of the lymph system and down into the bloodstream. Let's go. Here we go. You see they got little points on them. And they also can suck in enemies and chew them up and spit them out. They have several things they can do. And this guy says, stop! I mean, that's one of my cells. Get away from me. See, he can blow himself up. That's another thing they do. Kill themselves. And he says, that was close. But they also spit out acid and they destroy these people. See them? Eating them up? But when he throws that out, sometimes it kills these nice cells here. You don't want that. But that's what he does because he's out to kill anything and everybody. And let me tell you how far they'll go. Here's a guy that's blowing himself up. You see that? Makes this big mess, and the mess itself will kill things. And he's dying. I mean, he's exploded himself. And even after he is almost dead, watch what he does. Die! Stop right there for just a minute. I mean, you want those guys on your side. The neutrophils. The macrophages and the neutrophils are the big come after them guys at the beginning of any kind of infection or invasion. So thank the Lord for those. And they do all kinds of other things we haven't specifically talked about. All right, go ahead now. So here's activity down here, lots of action taking place. What happens next now, class, is your body starts reacting with lots of blood. Stop right there just a second. It infuses lots of blood so that it can bring in lots of specifics that float in the blood and help start closing that hole. We're not even talking about blood clotting here, but it's very important, and that's happening at the same time. So also it brings in a whole bunch of stuff. Keep going now. As that blood comes in there, you have a whole bunch of proteins. See all these little guys? That's called the complement proteins. And we're not even going to have time to talk about them, but they surround an enemy and blow him up. I like that. Stop. The complement system takes up 2 chapters in this book. We're not going to have time to talk about that. But it's another part of your whole defense mechanism that destroys enemies right and left. So they've been brought in now. Go ahead. You see, everybody's getting tired. They've been fighting hard. They're out on the battlefield facing the enemies. And here's where the dendritic cells come into play. These guys also suck in enemies, chew them up. And you know what this guy does? Stop. He spreads them all over his body. Is that disgusting? He takes the pieces of the dead enemy and he puts them all over the different things he has on his body. Why does he do that? Because he wants to find the specific T cell that'll kill that enemy. And so having this stuff spread on his body identifies the enemy for the T cells he's going to go looking for. So, because the battle continues to rage, this intelligence officer has decided it's time for me to take action. But he's not fast about it. Kind of takes his time and gets that stuff gathered and makes his analysis kind of like good intelligence officers would do to make sure they're doing the right thing. And then he proceeds. Let's go, Cody. He goes into the lymph system and starts looking around for the specific T cell that he needs to find for that enemy. And this is how you overlap. See, he's going up through the lymph system. Here he comes. And there's all kinds of nodes in there. There's places where those people hang out. Stop just a second. And he calls them there the, what did he call them? It's where you, what do you call it when you're hanging out trying to find a date? Anyway, there's a name for it he uses. He's looking for those dating places for T cells where they can find somebody to match up with. Well, the T cells have all been, there's lots of different kinds of them. They go floating through your lymph system all the time. They're traveling around your lymph system all day long. And they stop in different locations to find a date. And if they don't find one, they go on. So what this dendritic cell is looking for just the right T cell for that specific enemy. And once he finds him, this guy starts activating, as you'll see. Go. So this is to show you there are lots of different kinds of T cells. Millions of them that your body makes. And here's the one specific one you know. So how in the world is he going to find it? Well, he starts looking through these guys. He says, not you. I don't want you. Get out of here. You're the wrong one. But once he finds the right one, class, love at first sight. Stop right there. You see this little protein right here? He calls it a hamburger bun, a hot dog bun. And it holds the hot dog. And if you have that combination, and this is the right T cell, they hook up, and it's the right combination. It's got to be just right. There's a whole bunch of chemistry right there, folks, that happens to make the connection right. Now, once that connection's made and the antigen is identified and this guy says, that's my antigen, then watch what happens. He says, I love you. I love you. And then they kiss. And stop right there. He is now activated, class. And I know this is kind of a funny way of saying it, but that's exactly what happens. He's chemically activated now for that specific enemy, and he says, I need you. Now watch. And what happens is this little guy is kind of like a teenager who doesn't want to get out of bed. So watch. He keeps tapping on him. He says, folks, it's time to get to work. Get up and move. And so that's what he does. Having now been activated, he starts dividing. Poof. 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 Folks, in a matter of seconds, he's made 1,000 copies of himself. And every copy is identical. Stop. I'm sorry, Cody. Stop right there. Can you back up just a little bit to that slide before? Back just a little. There, right. You see, these are the copies he's made of himself down inside the lymph system. About half of them start going to the place where the battle is. The other half starts roaming around to find the B cells needed to take it to the next level. So, are you with me? The innate system has to activate the adaptive system. And that's the way it works. Of course, there's 68 other things I should tell you, but it's kind of the way it works. And once this thing starts with the T cells, then you start down the long-range protection of the adaptive system. Go. So these guys now are going to the battlefield. And here's the battlefield. They've been fighting now for days, and they're really getting tired. See how he just kind of wears out? I'm just going to look. I just soon go on and die. I've done my work. And here comes these T cells. These are called helper T cells. And watch. He comes up to him, and he injects him with a little chemical, some cytokines. He said, look, you got a job, fella. This is important. The man needs you. You need to stir up. And he says, all right, I remember. Watch. Arg! And it's get after them. And they're doing that all over the place. Stop just a minute, Cody. Look, these helper T cells are partly designed to help the innate system guys get back to work. And they make them become more efficient than they were before. And they get after it. And so everybody's fighting harder than they fought before, thanks to the next phase of this process. Go ahead. The other guys, in the meantime, have swum off in the other direction, and they're looking for B cells. And they got to find just the right B cell to go with the T cell. Of course, these are all identical now, so they're looking for the right B cell, and he's found him. So that starts to divide. And the B cells then come out here, and they start multiplying and dividing themselves. Lots of repetitions. Part of them become what are called producer cells. And they start making antibodies by the thousands. 2,000 per second is what they say. And they start sending those antibodies down to the battleground. Now watch while the antibodies invade here. See, what they do is they get these guys together. They clump them up. They surround them. Stop right there just a second. Antibodies, class, can't kill anything. Here's what antibodies do. Here he is! Come get him! And they glob them up so that the enemies can't get away, and it's easier for these macrophages and neutrophils to find them and blast them. So the B cells are helpful too. Go ahead. So here you see they've found them now. They wipe their way through it, and relatively within short order. Once this second level happens, your infection's over. So let's see what happens next. Here are a few of these T cells now. They go floating off here, and they become memory cells. And so they start patrolling your body, and every time they see this enemy, that enemy's in trouble. Watch. There he is. Stop right there just a second. Can you go back just a minute? I want them to see that guy. Just back up just a little. Okay. And stop when he gets down here. Right there. He's saying, Who are you? I remember you. You're the enemy we just got through killing. And he goes after him. And by the way, he can skip steps in the process now because it's already happened once. Folks, you older people have those things floating around in your body from previous diseases, helping protect you now when they recognize a former enemy. And they can do it much more rapidly than before. Okay, go. And here's the B cell. And you can see they're producing antibodies, but they also produce memory cells. And those memory cells stay in your body also. So you have B cells and T cells staying in your body for a long time. Isn't that fun? And you understood a little better what we're doing. All right, now for the next few minutes, and I'm going to watch my time. Let's go on to the next slide. You remember they said there were 4 big things? Recognition is the first one. You need to know who the enemy is. So in your body, you've got enzymes that help you identify them, macrophages, killer T cells, and antibodies. All of them help identify enemies. And we're not going to talk about each one of them, but they do. I do want to talk just a minute about antibodies. You've all heard of antibodies, haven't you? You need antibodies to fight the enemy. And these antibodies are very specific. So they're connected to the B cells first, and they form this antibodies. You see that unique shape? Let's go on to the next slide. Every antibody is made up of 2 long chains and 2 short chains. It's called the heavy chains and the light chains. And at the end, you see what's up top there? There are little specific chemicals up here that are called the binding sites. And they are specific for a particular enemy. Specific. That's why it's so important to find the right one when you're fighting. So how do you get, let's see what the next slide is. Well, here's the process. The immature B lymphocyte, once it sees the antigens and it connects them up to that particular one, starts multiplying. One becomes a plasma cell, another becomes a memory cell. The plasma cell makes lots of antibodies. The memory cell starts circulating in your body, and the antibodies go down there and help the battle. That's what happens. The question now is, how do you get such diversity? Because there has to be diversity. There are lots of enemies out there. Well, you have to have barriers. You have cellular and adaptive processes, but you've got antibodies that have diversity going out the window. So here's a little brief chart to show you how the body does that. Back in your stem cell, you're making B cells all the time. And the B cells you make are lots of different types. Here's the first round. It's made a lot of different types of enemy detectors. If this particular enemy detector finds an enemy, then it starts multiplying itself. So you get this kind. If this particular one, or this one down here, finds its enemy, it starts making its kind of antibody, so that enemy can get killed. But the question is, how does your body make all those different kinds? That's a good question. So, if I explain this properly, we would need the next 2 hours. So I'm going to tell you just briefly, it's like this. Ladies, if you were going to have people over for your dinner, and you're having lots of different people, and you want a different dinner every night, if you had like 6 vegetables, 7 meats, and 3, starches. You can mix and mingle those, couldn't you? And have lots of different meals, and almost a different one every night for a long time. And then if you add dessert, you could have even more mixes. Well, the way your body does it is the DNA has parts of the DNA that go to make up the long chain. See this long chain here? To make that long chain from the DNA, you have 65 fragments over here in this variable region. You have 27 fragments in this region and 6 fragments in this region. You can pick from here, here, and here to make this guy. Well, there's 65 times 27 times 6 possibilities. That's 10,530 different kinds. That's just for making the long chain. Then you got to make a short chain. See this one here? There are 40 fragments in your DNA for that, and 5 fragments here. You can pick from any of those combinations. 40 times 5 is 200 different types. But to make an antibody, you need both a short and a long. So let's go to the next slide. You have 10,530 possible long chains, 200 possible short chains. That's 2,106,000 different types. But there's another key to this. You can mix and mingle, and you can have partial ones. So this ends up being billions. Built into your DNA that your body can make of B cells and T cells, by the way, so they're identifying any enemy you'll ever have. It's the largest library in the universe of information. And then you got to kill things. Well, enzymes can kill things. Cytotoxic T cells are the best, and the complement pathway. I want to talk about cytotoxic T cells. A T lymphocyte that's immature has to go to school, class. They are matured in the thymus gland. Right up here. Extremely important. Now, what I want to read you is about the thymus. So let me find this. Get my page number here. All right, I should have marked that. Hang on just a second. You know what the thymus university is called? Anybody know? What is the thymus university called? Well, aggravating. Hang on just a second. It's 39. TCU. It's called Murder University. So I'm going to find you the chapter on Murder University. Here it is. As you can imagine, the body takes issue extremely seriously when it comes to T cells because they can kill you. So every T cell has to go to Murder University in the thymus. After a fresh and young T cell has been born, it travels to the university to begin its training, which consists of 3 steps, or better, 3 tests. The first test is just basically making sure the T cells have the ability to make working T cell receptors. Critically important. In a regular class, that would be like teachers checking if the students have all their notebooks and the required reading material with them. Only they would not send the students home if they forgot something, would they? But in this university, if they don't have the ability to build receptors, they take them out and shoot them in the face. This is a tough university. If they pass the first test, there's a second test. It's called the positive selection test. Can they do a great job of identifying or recognizing the receptors of the cells they'll need to work with? Imagine this as part as if a teacher checks the pens of students if they're full of ink and the workbooks that are in fine condition. In other words, you've got to be doing this right. Again, what do you think happens if they fail the second test? They kill them. After the first 2 hurdles have been taken, the last and most important test waits. It's called negative selection. And this might be the hardest test of all. The final exam is simply this. Can the T cell recognize self? Can its receptor connect to the main proteins inside the body? The proteins that make you, you. Can this guy connect to them? And you know what the answer better be? No! You don't want T cells connecting to you. What do you want them connecting to, class? The enemies. So you know what your thymus does? It has teachers in it. They call them teacher proteins. They can bring in examples of proteins like insulin, other proteins that are needed in the body, and bring them into the thymus and see what this guy does with it. And if he reacts to any of them, he's dead. So 3 tests, all of which the consequences of a wrong answer is death. Is that my bell? Okay. I wanted to get through this at least. Class, do you want to take a guess how many T cells out of 100 get out of that university alive? That's a good guess. Wrong. Yes, sir. That's close. It's 2. On average, it's 98 out of 100 students get killed in this process. In spite of that, they graduate out of that university roughly 10 to 20 million T cells every day. That's the 2%. A lot of guys get killed. That's a bunch more dead bodies. What do you do with that? Well, macrophages go around and suck them up and eat them up. That's partly what that does. But you don't want T cells that'll kill you. So this is what the body has built. There's a university in your thymus. Isn't that incredible? To make sure the T cell fighter fights the right thing. All right? This is the complement system. All I want you to do is look at it. I mean, here's the classical pathway, the lectin pathway, and the alternate pathway. Every one of them is a reaction on 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 a reaction, and it finally blows it up. That's going on every second in your body. Complex chemical reaction. This is the complement system. I don't have time to talk about it. So we're going to skip that. Then you have to have toleration, the B cell and T cell tolerance. You know partly why they're tolerant? Because they've been trained. And 98 of them got killed because they didn't train right. And then you have regulatory T cells. So there it is, class. For your immune system, you got recognition, diversity, destruction, and toleration, all of which work together in amazing fashion to keep you alive. And you have a summary of it there, which I hope you'll kind of keep tonight. And when you say your prayers, you'll be reminded of the magnificent designer who made this so you can live against incredible odds. Because, folks, bacteria have a lot of advantages over you. One thing is they reproduce very quickly. You know how long it takes you to reproduce? To make another little creature like you? A long time. These guys can multiply and develop and mutate and reshift around. You don't stand a chance if you didn't have these guys. But you have an amazing system to keep you protected. The Bible teaches that things that are made cause us to see God. And when we look at the natural world, everywhere we look, things sure look like they're made, and everybody says so. And the most reasonable explanation is, we should all agree, God made them, and He's amazingly intelligent and powerful. And that's tonight's lesson. Thank you for your careful attention. I hope you had a good number of laughs with me, but it's serious business, isn't it? Thank you.